So, we've discussed the phases of the moon, but just so you know, we really only see one side of the moon. You may have noticed that because we see the same sort of features in the moon every time we look up at it. And that's not because the moon isn't rotating, it actually is rotating. It just rotates exactly once with every orbit. So, if we look at this diagram here, we have a girl sort of rotating around as she walks around this circle. If she rotates around exactly once, right? So every time she goes around that circle, then she keeps in sync, right? And so we only ever see her front, even though she's rotating. So that's why we get to see those features from on the moon all the time. Okay. So what about eclipses? Now, the moon and Earth can cast shadows. And when either one passes in the other's shadow, we get an eclipse. All right. So there are two types of eclipses. Well, actually, there's several, but two main types. That is a lunar eclipse and a solar eclipse. So let's go through each one. So when can lunar eclipses occur? Well, let's look at the geometry of this total lunar eclipse. And here's a picture of what it actually looks like. It's really beautiful. They occur quite often. So it's really nice to be able to see them. So in this geometry, the moon is in the Earth's shadow, right? So the sun's here, the moon is in the way. I mean, sorry, the Earth is in the way, and you get the moon right in the shadow of the Earth. Now, what actually happens is that the light from the sun, okay, is going through a lot of our atmosphere. So you can see sort of right here, if you look at this ray, it's going to go through a bunch of our atmosphere, and that causes it causes blue light to get absorbed, and so the moon ends up looking red. Okay. Now there's other types of lunar eclipses. There's partial and what's called penumbral lunar eclipses. The penumbral is not very exciting. You really don't see much of a change. You can see a little bit of a change in a partial lunar eclipse. But the really beautiful one is the total. And again, they happen quite often. Okay, what about solar eclipses? Well, they only occur at the new moon. Oh, and by the way, let's run back here just to point out. Notice what phase of the moon would this be for you to be able to see a lunar eclipse? It has to be the full moon. Okay, so they just don't happen unless it's full moon. Because look at the geometry, right? This is the geometry of the full moon, isn't it? Right, where we have sun illuminating, and you know, of course, the sun always illuminates half of the moon, but we see that whole half here, right? But it happens to be when the moon is in the shadow of the Earth here that we get this total lunar eclipse. And you may be wondering why we don't get this every single time there's a new moon. Well, I'm going to explain that in a second. Let me just go on to solar eclipses. All right, so in this case, it's a little different. We have the moon in the way of the sun, right? And the reason that we can get something like a total solar eclipse is because the size of the moon in the sky and the size of the sun in the sky are the same. In this diagram, it's certainly not drawn that way, right? But they are when we're looking up at the sun, if you took out an angle measurement, you would find that it's the same angular size as the moon in the sky. That's why you can get these total solar eclipses. Now, there's other types of eclipses. There's partial solar eclipses. And if you were at the last eclipse, which was in, I believe it was late August to 2017, if you were here in Lynchburg, you saw a partial solar eclipse. You had to drive somewhere to see the total. And I ended up driving somewhere. I'll show you some pictures from there to go see it. Okay, and then there's something called the annular eclipse. So notice here where the moon is not covering the whole image of the sun. So I just said they were the same angular size. So what's up with that? Well, it turns out they're not always the same angular size. So if you read your book, you might remember that that when something is closest to the object that it orbits, we call that perigee, and apogee when it's farthest away from the object that it orbits. And of course, if something's closer to us, it looks bigger. Farther away, it looks smaller. So if the moon is an apogee, right, and then you get a lineup for the solar eclipse, it's not going to cover the whole disk of the sun, right? And so you're going to get what's called an annular eclipse, and here's a sort of picture of that. Now, if we go back to our eclipse side, our solar eclipse side, notice this happens, a solar eclipse can only happen during a new moon. This is the geometry of the new moon. Remember from our simulation, right? It was when you've got sun, moon, then earth. And if the moon's on the other side, right, that's the full moon, and then you could have a lunar eclipse. Okay, so different configurations here. And just to give you a couple of cool pictures, we went down to Greenville, South Carolina to see the eclipse. This is my son in the pool with his eclipse glasses on. Of course, you could not look at the sun without those glasses. And it was a great experience because, you know, a lot of people went to big gatherings at parks or universities, etc. And we were at this really tiny, crappy hotel, and they had this pool, and we were like, why don't we just stay in the pool? It was very, very hot. And so that was a great experience. We had about 7 or 8 people there with us who were also at the pool. One of them took these great pictures, and I'll explain these in a second. But it was a great experience to be like in a pool watching the eclipse and drinking wine. Anyway, so here this is right before totality. Now, if you didn't wear the glasses and looked up, of course you could damage your eyes, but also you wouldn't see anything. It would just look like the sun, because you really can't see anything without the glasses because the sun is so bright. Even at totality, you really can't see anything. So you might have noticed, if you go on YouTube and look around, there's lots of people like taking iPhone videos of the eclipse. And if they don't have a special filter on the iPhone, it looks just like the sun. It just gets darker. Like the actual, you know, outside gets darker. But it's so bright that even at totality, you can't tell there's an eclipse without the filtering of glasses like these. And so the person taking these pictures had a really beautiful camera with a filter, so that he, you know, basically the same kind of filter as Finn's wearing there, that's my son, and to actually take these pictures. But anyway, here's the sliver right before totality. Here's a picture right at totality. And then right as the moon starts to move off, you see this thing called the diamond ring, which is this flash, you know, of light, because the little bit of the sun is now being exposed. You can kind of see the start of it here. So he didn't catch this right at totality, right in the middle of the totality. This was right sort of towards the end, and we get the diamond ring. Anyway, it was a great experience, and I highly encourage you to attend the next one, which is one of your questions on a quiz about when are the next lunar eclipses that you could see from here. When is the next solar eclipse you could see from the United States? Anyway, so the question you probably are wondering about is, why don't we see an eclipse every single time there's a new moon and a full moon, right? Every single time there's a new moon, why don't we see a solar eclipse? Every time there's a full moon, why don't we see a lunar eclipse? Well, it turns out it's because the moon's orbit around the Earth is inclined, so tilted, from the ecliptic. So think of the ecliptic as this sort of water pond here, as we've drawn in this diagram, right? Here's the ecliptic. It's the surface of this water pond. The plane of the ecliptic is that surface. And the moon kind of rises up and dips beneath, and rises up and dips beneath. Okay, so basically, the only time you get eclipses are when the moon is right at the surface, right? Not below, not above. And the times when it's right at the surface of this pond, this fake pond here that we're using to represent the ecliptic plane, there's only 2 times during its orbit that it's in that plane, and those are called the nodes. So here's a new moon near node that's causing a solar eclipse, and a full moon near node that's causing a lunar eclipse. Okay, and over here, look over here, right? Over here, the full moon, this configuration, is below the ecliptic plane, so there's no eclipse. The nodes are over here, here and here. Over here, the new moon is above the ecliptic plane, so there's no lunar eclipse, right? So, I'm sorry, solar eclipse. Right, over here would be a lunar, if it was not below the ecliptic plane. So this just doesn't happen all the time. Okay, so just to remind you, the times when you have the moon right in the plane of the ecliptic, right at the edge of this water pond here, are called the nodes. All right, let's try some questions. All right. A total solar eclipse can occur only at what phase of the moon? So if you want to think about it a minute, you can pause the video, but we'll answer that. Okay, so let's let you can pause if you need to look at the question. You can also sort of run it back. I'll sort of run it back for you, and let's take a look at, not that, but here. What phase of the moon are we looking at here for a solar eclipse? Right? It only happens at the new moon. Let's go back to our question. Okay, so new moon, right? Okay. What a total lunar eclipse can only occur at what phase of the moon? Well, right. The new moon was when the solar eclipse happens, so it's the full moon when a lunar eclipse can happen. All right, the orbit of the moon and the ecliptic are totally aligned. Well, no, we just said that, right? The pond, which is the plane of the ecliptic, then the orbit of the moon are not aligned. If they were, we'd have eclipses all the time, or every time there was a new moon and a full moon. Okay, so that's false. All right, so now we have your question. So we have a question for you to answer. Again, you got to pause the video. So do that and answer the question.